All right, so integral, so recall that definite integrals, right, with bounds, give us an accumulation. Accumulation means total, right? So we know that f of x, capital F of x means total, right? Total area, all right, over an interval, okay? Okay, so first derivative of that is the rate of change, how fast the total is changing, right? How fast the total is changing. Second derivative is how fast is the rate of change changing. So it's kind of like velocity and acceleration, right? Velocity is how fast is something changing over time. Second derivative is acceleration. How fast is the rate of change? How fast is velocity changing over time? It's kind of that idea, okay? But just remember that integrals mean accumulation, total, okay? So if we find an integral, area under the curve, it means a total, all right? Okay, so first thing is distance versus displacement. Distance versus displacement. Okay, so distance means how far you travel, right? So if I get in my car here and I go to East Campus, I get in my car and I drive, that's how far distance is. How far did I go, right? Let's say I have to go home, so I go home and then I come back. That's one trip, right? Go home and come back. So I just add up the distance and however many miles, right? That's distance, total distance. Displacement is a little different. Displacement is how far are you from where you started. So if I start here, like, oh, shoot, I forgot something in my home. So I start here and I go home. And then I come back, right? Displacement is 0 because I'm exactly where I started. Distance is not 0. I had to travel to my house. Then I had to travel back, right? So same thing, if I go to East Campus, for something and I go there and I stay there, displacement and distance are the same. But if I get in my car and come back, distance got doubled, but displacement became 0. That's the difference between displacement and distance, okay? So consider the following statement. 2 steps forward, 1 step back. So if I take 2 steps, 1, 2, and then I take 1 step back, how many total steps did I travel? 3, right? That's the first one, 3 steps. Right? What was my displacement? So let's try that again. 1, 2, go back 1. Displacement says, how far are you from where you started? 1 step, right? I'm 1 step away. Even though I traveled 3 steps, I am 1 step away from where I started. That's the difference between displacement and distance. They're both kind of the same thing, okay? All right, okay, so that's verbally what it means, and that's kind of the definition. How do we do it multiplication-wise? Okay, so if we were looking for displacement, change in position, where were you then versus where are you now, right? We're going to integrate the rate of change. So you're going to find the area from A to B for the velocity. That's the first derivative, right? So you're going to find which will give you this guy, right? Okay. If you're looking for total distance traveled, that's a little bit different. That's the antiderivative or the integral for speed. Well, speed is the absolute value. So that's where they're a little bit different. Oh, I forgot to tell you guys. Grab a calculator if you don't have one, or if you have your phone calculator, grab a graphing calculator because we're going to use one. So whatever calculator you used yesterday, just grab that. Okay. If you want to use the app or you want to grab a calculator because we're going to use it today. I'm going to show you some more stuff on the calculator. Okay. Yeah, just grab one from the back if you need one. I forgot to tell you guys at the beginning. Sorry. Okay. Okay, so distance traveled is just the absolute value. Because remember, speed determines the distance traveled. If I get in my car, can't have a negative distance, right? I can't go negative distance. So that's why it's speed. That's why it's absolute value. New position, that's one we're going to see quite a bit. New position, where are you at now? You take your old position, and then you add whatever the change was, right? What is the change, right? So how do we do that mathematically? We take our old position, where were you at to begin with, and then you add in your displacement. Okay, you add in your displacement. That's how we're going to do that. Okay, so we're going to be doing those a lot. Mainly new position a lot. Okay, because they're going to be asking about that. Okay, this is from last semester's notes, but you're going to see velocity, acceleration, all that stuff, so I put it in here. So when is an object moving left? When velocity is negative, less than 0. When is an object stopped? When velocity is 0. When is an object moving right? When velocity is positive. Just a reminder, okay? No, you don't have to worry about the vertical line. Vertical line we really don't talk about, which is mainly horizontal. Okay? All right, so let's look at the second example. Okay. So suppose the velocity of a particle moving along the x-axis, left and right, is given by v of t. 6t squared minus 18t plus 12 when the interval goes from 0 to 2. Okay? When is the particle moving to the left? When is the particle moving to, or vice versa? When is the particle moving to the right? When is the particle moving to the left? When is it stopped? Okay? So tell me, when is a particle moving to the right? When do we consider it moving to the right?
When
Say?
velocity is greater than 0.
Velocity is greater than 0. Velocity is positive, right? It's moving to the right. Opposite is true. When it's moving to the left, it's when velocity is 0, right? And when is it stopped? When it's equal to 0. Good. So I'm seeing a lot of v of t's. So we're going to need v of t. Do we have v of t? Yes, right here. Last semester I asked you the same question, but I didn't give you v of t. I gave you s of t or x of t. I gave you position. So we needed to find the derivative and then go there. But now you already have velocity. So I need to figure out where is that. First thing I'm going to do is figure out where is it 0. Okay? So I'm going to set this equal to 0 to figure out where is it equal to 0. Right? Where is it equal to 0? Well, it's a trinomial. So it has, I can divide them all by 6. I can divide all 3 terms by 6 to make it a little bit smaller. It's a quadratic, right? So then I factor. So I got to come up with the 2 numbers that multiply to be positive 2 and add up to be negative 3. What are the 2 numbers that multiply to be positive 2 and add up to be negative 3? Negative 2, negative 1. There we go. So then you set those equal to 0, right? T minus 2 equals 0, t minus 1 equals 0. And you get t equals 2 and t equals 1, right? So what does that tell us? When it moved to the right, moves to the left, or stopped? So to the right means greater than 0. We didn't find when it was greater than 0 yet. What did we find? When it was equal to 0. So when it stops, right? So that means the object is stopped at positive 1 and positive 2. Okay? So we got 1/3 of our answer. Now, how do we determine, what do we use? What do we use to determine when it's positive and when it's negative? You've done this, you did this many, many times last semester. I think we've done it a couple times this semester. What do we use to determine when velocity is positive and when velocity is negative? Does anyone remember?
Find the derivative.
We already have the derivative, right? We already have the derivative because we have v of t. So you're getting there. There you go, the number line, right? The number line. It's the first derivative test, but we didn't have to do the derivative because they already gave us velocity. Okay? So we put the two that we found, the critical values, right? Which were when velocity was 0. And then we plug in numbers less than 0 or less than 1, in between, and greater than 2, right? So like, for example, I can't pick 0 because the interval starts at 0, right? Actually, it should be something like that. It should be more accurate. It should be that, right? Because it can't have negative time. It starts at 0. And there is nothing bigger than 2, right? Because the interval just goes from 0 to 2. So really, the number line is really a segment. Okay? So I need to pick a number in between 0 and 1. I'll pick 0.5. Now, all I care about if it's positive or negative, right? I'm going to use this guy here. I'm not going to use the original. I'm going to use this guy here. It's the same as this guy, and it's the same. They're equivalent. They're all equivalent. The reason I'm using the green one is because it's easiest. So we have 6 times 0.5 minus 2, and then 0.5 minus 1. So I have 6 times negative 1.5 times negative 0.5. Again, I could care less what number it is. I just want to know, is it going to be a positive or negative number when I multiply all those? So what is it going to be, a positive or negative when I multiply 6 times negative 1.5 times negative 0.5? Two negatives make a positive. So in between is positive. Now I'm going to do the same thing, but for a number in between 1 and 2. $1.5. So we get 6, negative, excuse me, negative 0.5, positive 0.5. So when I multiply those three numbers, is it going to be a negative number or a positive number? Negative, yep. Only one negative, get a negative. All right, so let's sum it up. Let's say object stopped at t equals when t equals 1 or t equals 2. Okay. So let's say object moving right. Right arrow means moving right. We said moving right means greater than 0, positive, right? So that's going to be from 0 to 1. 0 to 1. Because v of t is greater than 0. And then object moving left is from 1 to 2 because v of t, oops, I'm running out of room here. V of t is less than 0. Okay. That's kind of review. Not anything new. We've done that before. It's good to remind ourselves, though. Okay. So now let's go to letter B on the back side. Now we see a word that we haven't seen yet. Displacement. We haven't seen displacement at all this semester. Today's the first day we've seen displacement. Okay? So it says, find the particle's displacement over the interval, right? What is the interval? Remind me what the interval is. 0 to 2. So go back to the first page. We saw the word displacement, right? What did it say displacement meant?
How many steps away from its starting point to its ending point?
Okay? But right now I'm not talking about steps, right? So how do I find displacement? With steps, you're right. How do I find displacement? What do I need to do?
Find the antiderivative.
Find the antiderivative from A to B for velocity. Okay? So from A to B, so what's A and what is B? V of t, right? dt. So in other words, 0 to 2 for velocity, which we just had, velocity was 6t squared minus 18t plus 12 dt. You guys have done this before. You guys have had tests and quizzes on this. So I'm going to use the power rule. So when I use the power rule, I get 6t to the third divided by 3 minus 18t squared divided by 2 plus 12t. And I have to evaluate it from 2 to 0. So in other words, I have 2t cubed minus 9t squared plus 12t. And I have to evaluate that from 2 to 0. So I'm going to plug in 2, plug in 0, subtract them. So I'm going to plug in 2 first.
Wait, we won't put like plus C or anything like that?
Nope, because I bounce 0 to 2. Okay. We've done this part many, many times. So now I got to do my number crunching. Well, the easy one is the second one, because 0 cubed times 2 is 0, minus 0 squared times 9 is 0, plus 12 times 0 is 0. So that guy's going to be 0. This guy is a little more, I have to do a little more number crunching. So I get, let's see, 2 cubed is 8 times 2 is 16. 2 squared is 4 times 9 is negative 36, plus 2 times 12 is 24. So let's see, it'd be negative 16 plus 24. No, negative 20 plus 24 is 4, right? 4 minus 0 is 4. Okay. On C, I'll teach you how to do it on the calculator. I wanted to do B because you've done that before. C, I'll show you on the calculator. So that means displacement is 4. 4 steps. 4 doesn't give us anything, right? It doesn't give us any measurement or time or anything, so just 4 something. Okay. Okay, so now let's find the total distance. So go back to your cheat sheet in the front. How do we find total distance? What's the mathematical way of finding total distance?
Find the derivative of the speed and then...
Antiderivative, yep.
Oh yeah, antiderivative, and
Yep.
then antiderivative of velocity.
Yep, that guy right there. Okay, so it's the same thing, the only difference is absolute value. And that's why it says calculator question, because they won't make you do this by hand. Okay, so let's write though. We got to write what we're going to solve. So what we're going to solve is from 0 to 2. That guy, right? Which more specifically is 6t squared minus 18t plus 12. Okay. Okay, so now go to the calculator. I'll show you how to do this. So it'll show you two things. It'll show you where absolute value is on the calculator, and it'll show you how to do integrals on your calculator.
We do with them if it's dead.
Get another one. Just leave that one on the desk right there so I can charge it. And just grab another one. Okay. No, not that guy. All right. Here we go. Okay. All right. So, oops. Okay, so first thing we got to do is calculate, right? We want to calculate. We want to calculate area. So hit calculations. If there's anything written there, you can clear it. How do you clear it? Hit shift and then clear. Hit shift and then clear, and it gets rid of everything. Okay. Okay, so integrals. So integrals, yesterday I told you guys that if it's not on the keyboard, it's probably most likely in the toolbox. So you're going to hit the toolbox there. You're going to hit the toolbox, and it's going to give you a bunch of different options. We want absolute value, but not yet. I want integral first, right? So I'm going to scroll down until I see calculus. And the first one is derivative. I don't want derivative, so I'm going to skip the first two. I want integral. Okay. 0 to. Okay. Now I'm ready for absolute value, right? So let's go back to the toolbox and let's go absolute value. So the toolbox is there. I'm going to go back up. Oops. I'm going to hit the back arrow. I'm going to hit the back arrow to get back to the original menu. And then now I'm going to go up to absolute value. So now I'm going to plug in my equation. I'm not going to be able to use t because this one gives me x. So you're going to go 6. Variables are up here where it says cut, right underneath the black on button, power button. To the, that's right underneath the clear. This one is second power. Then hit arrow. Minus 18t plus 12. Okay. Hit enter. And we got a number. So how do you do integrals? Same way, you just don't have to use absolute value if you're going to do it. Okay. Okay, so 6. We got the number 6. So since this is a calculated problem, I don't have to show the work. I just have to show what did I use to get my answer. Okay. So again, 6 steps, 6 miles, 6 feet. I don't know what it was. They didn't tell us, but it's 6. So why? I have a question. What does it tell you when total distance and displacement are different? What kind of insight does it tell you? Displacement was 4. Total distance was 6. What does that tell you?
That it made more steps to be in its final position.
Okay, so keep going. What does it tell you, like, about the trip? What does it tell you about the trip?
The total amount of steps.
You're getting there, not total amount. What does it tell you? If displacement and total distance are different, what does that tell you? I backtracked a little bit. Yeah, I backtracked a little bit, right? If it's steps, then it's 1, 2, 3, 4, right? Or wait. So I took probably like a half step or something, then kind of backtracked back, right? So you went a little bit further, but then had to backtrack back. That's what it kind of tells you. Okay. Okay. Let's go to D now. So D, they don't want you to actually solve this. They want you to just set up the integral, just in case I wanted to. So what they want to do is set up an integral to find the total distance. So they want me to get 6, right? But I can't use absolute value. So what does absolute value do, though? What does absolute value do? Like, I know it's distance from 0, but what does it do, like when we're trying to solve answers? What does absolute value always end up doing to numbers or anything?
It makes it positive.
It makes it positive, right? It turns anything negative to positive, and it keeps everything that's positive, positive, right? So that's what we got to kind of talk about, right? We got to kind of talk about the backtracking a little bit. So if I took 6 total steps and I backtracked a little bit, what am I going to do? What operation am I going to show that with? Well, let's go here. Go back to the first page, the bottom of the first page. So picture this is a number line. I'm on a number line. Right, left. Okay, started at 0. Which way did I go first? Right. Until I got to what number? 1, and then what did I do? Backtracked, right? That's where I backtracked. So where did I backtrack? At 1. So what I have to do is find the area. So right now what I know is the displacement. I know how far I went to the right, and I know how far I went to the left, right? I ended up 4 from where I started. What they want me to do is figure out what was the total without using absolute value bars. Okay, so it was 2 trips really, right? It was, I went right for a little bit, and then I went left for a little bit, right? Okay, so let's set that up. So the first one, let's talk about right. When did I go right? From where to where? 0 to 1. So if I wanted to find total distance, I went to the right. It would be 0 to 1, and what would be here?
The velocity.
The velocity, right? So that's 6t squared minus 18t plus 12 dt, right? So that tells me how far I went to the right. But then I backtracked, right? When did I backtrack? From where to where?
At 1.
From 1 to 2, right? Same thing. How far did I backtrack? This is what it would tell me, right?
So these are separate equations.
They're separate because one is to the right. That's a good question. That's a good point. Let me put this to the right, to the left. Object moved left. Okay. I want to find total distance. What do I need to do with these two guys? See, you would think add them, right? And it is adding, except you got to think of it the direction, right? So if this is positive, let's say I went positive 6, right? And then I wanted to add, but I'm going which way? Left, negative, right? So you are adding, but what are you adding? A negative number. So really it's subtraction, yeah. And there you go. Now let's do some practice. Put that in your calculator. It doesn't say solve. But let's put that in our calculator and make sure we get, what answer should we get?
A positive answer.
No, we know what the answer is. What's the answer for total distance? 6. We should get 6. I'm going to show you a quick way to do it. So go back to your calculator. I'm going to show you a quick way to do it. So we still have that integral there, right? It lets you cut and paste. So hit enter, and it cuts and pastes. I don't want the absolute values, right? So I'm going to delete, how do I get rid of, I guess I can't until I have to, okay. So we did 0 to 1, right? We did 6t squared minus 18 plus 12. And then we subtracted, right? We added a negative because I went the other way. So I need the integral again. So watch this. Or actually, yeah, let me go back. So let me go to integral from 1 to 2. The same thing. 6t squared minus 18t plus 12.
Right, how did you copy and paste?
Hit enter. Enter is the exe. Copy and paste doesn't work so well for this one because it gives you the same exact problem. I don't want the absolute value. If you want the same thing, it does. So what you do is you just go up to it, hit enter, and it'll paste it, copy and paste it at the same time. Okay. What did I do wrong? What did I do wrong? What did I leave off? I must have left off something. Oh, syntax error. What did I leave off? Minus. Oh, let me see. I probably should be parentheses. No, I don't think I need parentheses, though. Wouldn't hurt, but I don't think I need parentheses.
So good.
Let's see. I don't know why it's giving me syntax error. I'm not sure why. It shouldn't, but I have a feeling it has to do something with this first guy. Oh well. Okay.
But it equals 6.
Yeah, it equals 6, yeah. If I had time to figure it out, I think it has something to do with the first one because you see this integral is a lot bigger for some reason. I think I did something wrong with it. I think when I copy and pasted it, I shouldn't have, or I did. Yeah, so yeah. Okay. Okay, so. All right. Okay, so now let's go to example number 3. We're not going to finish example number 3 because example number 3 is a big problem. So the example number 3 is a problem that I used to use for FRQs on test days. It was one of the FRQ questions that I gave. I liked it. There's nothing wrong with it. It's a great question, but after a while I used different problems. So you can pretty much write it down right now that you're going to have a question like this on FRQ day when we eventually take the test. I think our test is in a couple weeks, 2 weeks or something like that, okay? So yeah, okay. All right, so this is one of the most popular type questions for the actual AP exam. They like these types of questions because it involves integrals and it involves some derivatives, okay? And it's what we call a application problem. It's real stuff, okay? Okay, so here we go, let's read it. The tide removes sand from Sandy Point Beach at a rate modeled by the function R. A pumping station adds sand to the beach at a rate modeled by the function S, given by that. Okay, so let's stop there. Sand is being removed from the beach because the rip tide pulls stuff in, right? Anyone you guys have been to the ocean kind of pulls you into the water, right? It does the same thing with sand. So sand kind of pulls away into the ocean, okay? So how fast is sand going away into the ocean? R of t. Okay, that's the equation we would use. That's the rate, right? So let's write this down. This is a rate. Okay, it's not total, it's a rate. So we're right here. Okay. At the same time, because beaches are losing sand, they occasionally will add sand to the beach, right? How do they do that? A pumping station. They have pumping stations with sand. I don't know where they get the sand, but that's what they do, okay? So they're adding sand to the beach. How fast is sand being added to the beach? S of t, right? It's another rate. Okay. Okay. In between that, there's already sand there. There's already sands, right? So three things are happening. Sand is leaving the beach, R of t. Sand is being added to the beach, S of t. There's already sand there, right? Beaches have sand already there. How much sand is already there? 2,500 cubic yards. Cubic yard is so like a box this tall, this wide, and this deep. So pretty big, full of sand. So 2,500 of those. Okay, it's pretty. There's a lot of sand. It's a beach. Okay, so let's kind of draw a picture. Let's kind of draw a picture, formulate a picture in our head. So before I do these, I kind of want to do a picture. Okay, so this is what's going on. Okay. There's the sand. Looks more like water, but it's sand. Okay. Two things are happening. So there's, how much sand is there right now? 2,500, right? Yards cubed, right? That's how much is there right now. Sand is being swept away. Sand is leaving the beach. How fast is it leaving the beach? R of t. And sand is being delivered onto the beach. How fast?
S of t.
S of t. Okay. Okay, so there's three things happening. Okay? So what we have to do is answer these questions based off of that. Okay, it's a calculated question because we're going to use calculator. All right. So let's look at A. How much sand? So right there, what is it asking? How much sand? Right there, those three words. What is it asking for?
How much sand the tide removed from the beach during 6
Well, no, I'm just talking about how much sand. What is it talking about?
Removed?
No. Total, right? Up here. We're up here. Total. If they ask how much, they want a total. So we're up here. So it's asking for us to be up here. So if they give us rate, antiderivative, right? Okay. Will the tide remove from the beach during this 6-hour period? So the total is for the removal. Has nothing to do with what's already there. It has nothing to do with what's being pumped on there. Okay? So removal. Removal is R of t. What is R of t? Where on that list? Is it a total, is it a rate, or is it a rate of a rate? It's just a rate. It's just a rate. So if I want to go from R of t to how much, what do I need to do? Integral. So I'm going to need to set up an integral. Good. I'm going to need to set up an integral. What is the integral going to look like? This is what it's going to look like. Okay? Because, yeah, that means total. Right?
It would be 6 to 0.
So from what time to what time? 6-hour period, right? So from 0 to 6, good. What am I integrating?
RT.
There you go, R of t, the rate of the removal, R of t. Now you don't have to actually write, when you're answering these questions, you don't have to actually write 2 plus 5 times sine of 4 times 5. You don't have to do that. They've already defined what R of t is. So to refer to it, you just have to put R of t. How do we answer it? Calculator. So let's go to our calculator. Shift, clear, shift, clear, everything's gone. So we need to find an integral, right? What's going on? Okay, so here we go. Make this bigger. Let me make this bigger. There we go. What am I doing? Back. Okay. So we need to go toolbox, down to integral. Oops, skipped it right there. Integral. From 0 to 6 for R of t. Now the calculator doesn't know what R of t is, so I can't say R of t. I have to actually put in what R of t is. Okay? So R of t is 2 plus, sine is above the 7. Inside I have a fraction, so I got to put division. So on top it's going to be 4 pi t. So 4 pi is kind of above the 9 t. And then, oops, yeah, sorry about the 5. I forgot about the 5. 5 should go there, yeah. 5 sine, yeah. And then 25. Okay. That matches what R of t is, right? Hit enter. Okay. So how far do we need to go? Usually 3. I say 3 past the decimal. So 31.816. 31.816. Okay. Here's my question now. What is the units? So let's go back. This is the easy way to do it. Let's go back to our chart. Which one did we just find? Total, right? Total. It's not a rate. So how do we represent totals? As just amounts, right? So how much sand, how do they measure sand? Cubic yards, so yards cubed. You don't need for this guy, you do not need a overtime or anything because it's not a rate. So yards cubed. Or you could just say cubic yards. You could write cubic yards too. All right. Let's go to B. Write an expression, y of t. Okay, so they want us to write y of t equals. What is y of t going to represent? The total number of cubic yards. So what are we going to need?
The antiderivative.
Integral or antiderivative. Yeah, we're going to need one of those. We're not there yet on what, but we will get there. The total number of cubic yards of sand at any time. At any time. So it doesn't say at hour 6, hour 5, it just says at any time. Okay? So this is accumulation over the hours, right? It's 6 hours, but they don't want us to find for any particular time. They're going to do that for C. Okay. So let's go back to the front page. Even though this seems kind of like, wait, we're not going anywhere. Nothing. It's kind of like this, right? So they want us to know. So what's happening on the beach again? So let's talk about what's happening on the beach. What's happening on the beach during this 6 hours? There's sand leaving. It's gaining sand. And then what's the other thing? It's not really happening, but it's also important.
The amount of sand that's already there.
It's already there, right? So we have to take into account all three of those, right? So this one is considered new position. New position, right? S of A is going to be what's already there. What already happened? We have 2,500, right? So 2,500 plus. So I already took care of the sand that's already there. So what are the two variables that I need to take care of now?
RT and ST.
Leaving, coming on. So if I want to find at any time, at any one moment, if I want to find how much sand is there, what do I got to do with R of t and S of t? Subtract them, right? How much is leaving? Or sorry, how much is entering? How much is coming on? Minus how much is leaving, right? Okay? That's where our integral is going to come from. So it didn't say specifically what time, it just said t, right? So we're going to go from 0 to t. We're going to say S of t minus R of t dt. S of t has to come first because that's the part that's being added. You're subtracting the added minus the leaving, right? So can I do R of t minus S of t? No. You can't do that because then that's reverse. You'll get a negative number. We don't want negatives. Okay? Yes? Yeah, go ahead. Yeah. Go ahead. Yeah. Go for it. Yeah, we're almost done here. Actually, you know what? Let's stop here. I don't want to go on to the next one because we only got 8 minutes, and I don't think I'm going to finish the next one in 8.